Welcome to the world of Python web scraping. In this session, learn how to extract HTML data using the BeautifulSoup library. Web scraping is extracting data from websites. We'll focus on using Python and BeautifulSoup to make this process easy and efficient. Let's understand BeautifulSoup. It is a Python library designed for parsing HTML and XML documents. BeautifulSoup creates a parse tree, enabling you to navigate and search the HTML structure. It simplifies extracting data from web pages. BeautifulSoup works with different parsers like HTML parser, LXML, and HTML5 lib. It simplifies navigating complex HTML structures. To install BeautifulSoup, use pip install BeautifulSoup 4. To set it up, import BeautifulSoup from the BS4 library and import the requests library. Get HTML content using requests.get with the website address. Then create a soup object by parsing the HTML content with BeautifulSoup, HTML, HTML parser. Now let's explore some basic element selection methods in BeautifulSoup. The find method returns the first matching element in the HTML. The findAll method returns a list of all matching elements. The select method uses CSS selectors to find elements, providing more flexible targeting. Select1 returns the first match using a CSS selector. The getText method extracts the visible text from an element. The get method is used to retrieve the value of an attribute. For example, find the first paragraph using soup.findP. Find all links using soup.findAll. Find elements by class using soup.findAll, class_equals_container. Find elements by ID using soup.find, ID equals header. Using CSS selectors, items equals soup.select.item-class. Finally, get text from an element with title_text equals soup.find, h1.getText. Let's explore how to navigate the DOM tree using BeautifulSoup. The .parent property returns the direct parent element of a selected element. The .parents property gives you access to all parent elements in the tree. The .children property allows you to iterate over the direct child elements of a tag. The .descendants property gives you all the descendant elements. .next_sibling property helps you find the next element at the same level in the DOM tree. Similarly, .previous_sibling allows you to retrieve the previous element at the same level. To see this in action, get an element with element equals soup.find, div, class_equals content. Navigate to its parent using parent equals element.parent. Get all children with the loop. For child in element.children, print child.name. Find the next sibling element using next_element equals element.next_sibling. Finally, find a specific parent using section equals element.findParent, section. When scraping websites, it's important to follow some best practices. Always respect the robots.txt file and the website's policies to avoid legal and ethical issues. Add delays between your requests using time.sleep to prevent overloading the server. Use proper user agent headers to identify your script as a legitimate browser. Implement robust exception handling to manage errors and prevent your script from crashing. Store the scrape data in a structured format such as CSV or JSON for easy analysis and future use. Here's a complete example: import requests, import BeautifulSoup from BS4, and import the time module. Set headers to include a user agent, such as Mozilla 5.0. Get page content using requests.get with the URL and headers. Parse the HTML content using BeautifulSoup. Extract book titles, create an empty list called books, loop through each book item using soup.select.book-item. Extract the title from each book item using book.select1.title.getText, and append the title to the books list. Let's delve into some advanced topics in web scraping. One common challenge is handling content that is dynamically loaded with JavaScript. Another advanced technique involves working with forms and authentication to access protected content. For large-scale scraping, using proxies is essential for distributed scraping and avoiding IP bans. Implement rate limiting to respect server capacity and avoid overloading the website. Advanced scraping often involves parsing complex, nested structures to extract specific data points. Finally, store data in databases for efficient querying and analysis. There are several libraries to explore, such as Selenium for JavaScript rendering, ScrapePy as a full-featured framework, Pandas for data manipulation, and AIO HTTP for asynchronous requests. Check out the BeautifulSoup documentation at https://www.crummy.com/software/beautifulsoup/bs4/docs/single Practice sites include books2scrape.com, quotes2scrape.com, and webscraper.io/test-sites. Let's address some common challenges and solutions in web scraping. Many websites load content dynamically with JavaScript, making it difficult to scrape with basic techniques. Some websites employ anti-scraping measures to prevent automated data extraction. CAPTCHAs and login requirements can also block scraping efforts. Websites often change their structure, which can break existing scraping scripts. IP blocking and rate limiting are common defenses against web scraping. Handling large amounts of data can be a challenge. For dynamic content, use Selenium or Playwright to render JavaScript. Implement random delays between requests to mimic human behavior. Rotate user agents and IP addresses to avoid detection. Create robust selectors that can adapt to changes in website structure. Implement error handling and retries to manage failures gracefully. Use incremental processing for large datasets to avoid memory issues. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.